Go with today's what we did today in class. So this starts off by talking to us about the different ways that we can look at the trig functions. What we're looking at basically is they have a y and r. Y meaning the movement up, r meaning the distance of the hypotenuse. Um, I that's terrific, but I really prefer to stay with the big three, with the opposite over hypotenuse, adjacent over hypotenuse, and the opposite over the adjacent. And then right here we have the other six. So like if I take a problem like this, so here we are with this, theta's down here. So the first thing I do, this is going to be the opposite side, this is going to be the adjacent side, this is going to be the hypotenuse. Okay, so if I look at this, the sine of this is going to be 6 over 10. And of course that reduces down to 3/5. The cosine is going to be, again, we're going from theta, this angle, so it's going to be 8 over 10, which is reduced down to 4/5. The tangent is the opposite over the adjacent, 3/4. Okay, so that's all that we're doing here with this. I really stay with the big three. I really use those often. I keep going back and back and back and back to those. Once I know the big three, then it's not hard for me to come up with the secant, the cosecant, and the cotangent. It's easy to do. So let's say we have here, this particular problem gives us a lot of different things that we have to worry about. First of all, standard position of the angle. I don't have any idea what that is. So we start off by putting in the coordinate plane. And I'm going to graph this point, so I go over 3 and down 4. So there's that point. Now what I'm going to do is I'm going to make this particular triangle. I'm going to change colors with my pen. So now here's that triangle. Over 3, down 4, and I make my triangle. And this is in standard position because this is coming off there. The angle that I'm worried about right now is this angle. So what are the 6 trig functions? Well, first thing I want to do is, okay, if I'm talking about this angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So, and then I better figure out how long the hypotenuse is. Well, this is a 3, 4, 5 right triangle. So the sine of theta is equal to the opposite 4 over the hypotenuse 5. And then the cosine of theta is equal to 3/5 adjacent over the hypotenuse. And then the tangent of theta is going to be the opposite over the adjacent, so that's 4/3. All right, so now once I get the big three figured out, now I go on to their pairs. So sine, so this is the cosecant of theta. I just flip these over. The secant of theta, again, I just flip them over. And the cotangent of theta, flip those over. So those are my answers for this one. In standard position, this is how I would do this problem. Okay, in standard position, given that, so now we're going to have something that's a little different. This is -10, and I've gone down -24. Okay, so now again, this is the angle that I'm worried about. This is right angle. That's the angle. This is the opposite. This is the adjacent, and this is the hypotenuse. I know this distance right here, going from the corner out, is -10. I know the distance down is -25. And I want to be able to figure out the other distances. So I need to figure out the hypotenuse. So that means I would go -10 squared plus -25 squared is equal to c squared. So 100 plus, I wanted to say 625, but I don't think that's it. It is. So 25 times 25, it is 625. Equals c squared. So c squared is equal to 725. C is equal to, so let's see here, 725, the square root of 725. It's ugly. Okay, so this ends up to be, hold on, I got this wrong. This is a 24. So that means that this is not that. It ends up to be that this is 15. Excuse me, that this ends up to be, so let's see here, 10 squared plus 24 times 24. And if I take the square root of that, this is 26. So sine function, sine of theta is equal to, sine is negative 24 over 26. Cosine of theta is negative 10 over 26. And the tangent of theta is negative 24 over negative 10. Obviously, this reduces down to, I can divide both these by negative 2, so I end up with 12 fifths. I can divide both these two by 2, so I end up with negative 5 thirteenths. Divide this by negative 2, I end up with 12, 13. Another Pythagorean trouble, 5, 10, 5, 12, 13. Now, after I get those, the cosecant of theta is equal to 13 over 12. The secant of theta is equal to negative 13 over 5. And the cotangent of theta is equal to 5/12. Okay, the whole thing comes down to, in my opinion, comes down to my drawing and the big 3. Okay, in an angle, we have a right angle. And let's see here, this is the right angle, so this is P, Q, and R. So P to Q. Let's see here. So we're worried about the angle Q. So that means that this is the adjacent, this is the opposite, and this is the retirement. Excuse me, the hypotenuse. All right, so now let's put these in here. Q is 8, and this is 17. So 8 squared plus b squared equals 17 squared. B squared is equal to 289 minus 64. That's 225. If I take the square root of both sides, I believe I get 15. So what's the sine of Q? Is 15 over 17. The tangent of Q is going to be, let's see here. Tangent is the opposite of the adjacent, so it's going to be 15 eighths. Okay. Now we got another triangle. Z is the right triangle. This is X, this is Y. This means that X equals, this means that this is with Y equals, and this would be Z equals. So X is 6, Y is 4. How big is this? Well, these two sides that I'm given are the, let's see here, this is the opposite, the adjacent, and the hypotenuse. So these two sides are going to be, those two sides are going to be part of the tangent. So the tangent of X is equal to, let's see here, it's going to be opposite over the adjacent side. So now, once I get this, I'm going to go second tangent X is equal to 4, 6, which is, let's see here, second tangent of 4 divided by 8. So this is about 27 degrees. All right, this particular one is an interesting question because of the heights of the. So the plane's cruising along at 4,500 feet. And then goes up 1,100 square feet. All right. Now, how did it go up there? Well, it was at 47,000. Now it's at 56,000. How much did that change? Well, 56,000 minus 4,500. So I got this. 2.5 degrees. Want to know this. So the tangent 2.7 is equal to 1,100 divided by x. Multiply both sides by x. X times the tangent of 2.7 is equal to 1,100. Divide both sides by the tangent. (1,100) divided by the tangent. So there is 23,325 feet. Okay, plane descending. Here's my plane descending to my airport. All right, so let's go this way. Bad triangle. 5,000 square feet up in the air, 3 degrees. It wants to know my straight line distance. It wants to know this. Opposite over the hypotenuse. So that would be the sine of 3 is equal to 5,000. 5,000 divided by x. The sine of 3 times x is equal to 5,000. X is equal to 5,000 divided by the sine of 3. So 5,000 divided by the sine of 3 degrees is equal to 9,536.6 feet. Okay, I believe that's all that we've covered today. Tomorrow we'll review. Friday we'll take the quiz. Have a good night.